Again, everybody, we're back. It's episode 6. Today, the first of our mini movie reaches. Meanwhile, back at the ranch, from the old movies, right? Our hero would be off somewhere doing a good deed, and back at the ranch, the cattle are running loose or the outlaws are attacking. So it's today we're talking about planning, a favorite topic of academics, philosophers, and other people. I oddly enough have long experience of planning and a failure to resource the plan consistent with the plan's goals. So that will creep into our conversation. Okay, most planning is done in an organization top-down. They usually leave out validate from the bottom up. But just so you know that this class isn't about reading and listening to me, I have some sample problems from the chapter you should try. We'll post some solutions once I check that my solution and theirs are the same. Always a good thing to do, because interestingly enough, this textbook has been through 7 editions. And you might not know this, but usually the solutions are not done by the authors. Okay? Now, in engineering economy books, they're done by pretty much equally competent people. For example, the one we use in the undergrad class, no problem. The solutions are almost always dead solid. Once in a while, the solutions for this book are sort of mysterious, and they have a habit of having retained the problems from the previous edition but not having changed the problem number. So you're looking for the solution to say 53 and it's 51 from the old book and things like that. So we got to check that, and we'll post it so you could try it out. We'll have our first assignment coming up shortly. So, but try these problems, make sure they make sense. Okay, so we're going to plan some production, and you don't ask the right people all the time is the problem. Generally in here, I'll joke about, like, what do students want, right? And the answer to that question is go ask. Don't theorize. I find academics in general tend to be people who live in their minds a lot, and they think things through, and they come up with what you guys should want. And the most famous example of all is this class. Not this particular class, but using this classroom and running classes the way we run them. And I've been lectured at length on getting rid of what's called ITV, which is what we're doing here, instructional television. And I said, well, I have a lot of customers who like it. And they said, well, it's an antiquated technology, and you can do more with this, and you can do more with that. I said, you know, I'm pretty sure none of them want more. And most famously, I pointed out, I said, I have like 50-something grad students in this class. Now, you're telling me they could have taken the class from someone else, but they picked this one because why? And, of course, the big picture top-down didn't have an answer for that. And I had to point out to them that a lot of people who watch this class don't have web access where they are. Like they have web access on the weekends, or if they get off post, or something like that. And yes, I know the military has web access, but not necessarily to nmsu.edu, right? So, for example, you could, over a semester, carry a few DVDs. And when I pointed that out to the person who was pointing out the advantage of interactive web teaching, I said, I got a lot of people that are in different time zones. Are you telling me I should tell them to get up at 3 a.m. to watch me? And I said, I don't think so. I mean, I like this stuff, but not that much. I'm not getting up at 3 o'clock in the morning to do this. Why expect you, right? Okay, so in any event, watch out for that in every organization. Top-down planning, but no bottom-up validation. A dangerous habit. Also, apocryphal advice: plan your work and then do it. Implementing plans is always a dangerous adventure. Keep in mind that the fact that I joke about planning does not mean you shouldn't plan. It just means you need to do a better verification task of the plan. And our friend Montaigne, no wind favors he who has no port. You gotta know where you're going. So, the outline is, what's a long-term plan look like? How do we link it to what we do? Example, 5 years from now, we will have a new building built. We'll be doing what in the next 5 years? And in order to have the building occupied 5 years from now, we have to do what today? Like, if we're not digging a foundation, and so forth. Now, this is a class that talks about production a lot, so essentially, what kinds of aggregate units of production could we have? Example, Foxconn. They have big plants that make electronic things. Their units of production don't have to be specific to iPhone 7, but they do have to deal with the resources they have available, or the Intels of the world. They spend $1 billion on capital equipment, and it makes what kinds of stuff? Can it change models? The GMs and so forth. We talk about aggregate planning. How do we aggregate that? An example of aggregate planning would be, how many calculus sections do we need for all the different types of engineers who show up at a university? How many physics sections do we need? And my colleague, Dr. Zollner, rants, he's the head of the physics department, about physics 215 and 216. Included in the rant is the only real customer for those classes is the College of Engineering in aggregate. Then, for those of you who like this kind of stuff, there are tools for aggregate planning we'll talk about. There's the usual heuristic, means rule of thumb, if you will. How do we plan something? Simple procedures. We can do, if you liked ie524 and 590 with Dr. Sohn, or 413, then you'll love aggregate planning models. Me personally, I'm more in favor of heuristics, but that's what makes the world go round. You can do linear programs. If you have a background in the petroleum natural gas business, refineries use linear programs for planning. You know, what products are they refining? And it's sensitive to the market. What do we produce has something to do with what people are buying. In the winter, people buy heating oil. In the summer, people buy gasoline, right? You're planning mix changes. This sounds horrible, especially to someone who's not a native English speaker, disaggregating the aggregate plan. In other words, take the plan apart and put it together for real. We'll talk about some other tools. So philosophically, though, what's going on here? Numero uno, invest demand for outputs. That seems like a reasonable theory, huh? It gets expensive and wasteful, and you look incompetent, bad for the image when you overinvest or underinvest. Because we all know, everybody gets a class where they mention Machiavelli and his theory on new systems, right? Lukewarm supporters of the new, hateful supporters of the old who are happy to humiliate you, that kind of thing. In other words, if you invest in too many inputs, what are inputs again? People, materials, raw materials, plant to make things, right? If you want some evidence of this, you can look around New Mexico or wherever you live, and you'll see empty plants, right, that were built and now just occupy space. They're no longer needed. Turn them into whatever. We have some friends at Lehigh University who teach, they have an innovation lab in an old Bethlehem steel mill. They had the mill. They haven't made steel there in 88 years. It's sitting there dominating the skyline. It was a great deal for everyone. Now the students are using it. History-oriented people feel connected to America's industrial history. The university didn't have to build another building. Everybody wins, right? An easy example of this, by the way, is sooner or later everyone says, why are assignments all due at the same time? Like, why are tests all at the same time? And that's easy to explain. But usually I tell people it's a secret. I've been known to tell people when you get your PhD, they give you a secret list of instructions on how to conspire against students, including we all schedule everything due at the same time. And usually somebody believes that story, and I say, I can't believe you believe that. I said, Dr. Science, think about it. It's a 16-week semester. How much can you do the first few weeks? So all of a sudden there's a test, right? And all the classes operate starting roughly at the same time. Is enough material for you to do something after about, ding, 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 3 to 4 weeks. Then 3 to 4 weeks later, there's more stuff. And they, oh, I never thought of that. There were more, one time somebody was more willing to believe there was a secret conspiracy. And I said, have you ever listened to faculty? Nothing is secret. They talk endlessly. Okay, spoken like a true administrator. Let's move on. Long term, 3 to 5 years. Right now we are planning the summer and fall schedule. This year we had a major disruption to the spring schedule for the first time that I've been a professor. And that was Dr. Park, who teaches the senior design in mechanical and aerospace, and I had too many people in the senior capstone. See, the IE senior capstone traditionally is in the spring. So all of a sudden we had more people in the ME426, AE428, IE480 class than we had ever seen. Nowhere in our long-term plan did we anticipate there would be 150 kids who wanted in this class. So we had to implement a short-term solution which was kind of annoying to a lot of people. As a result, I got to give some number of speeches, like, if you are not graduating this spring, you may have to take it this summer or fall, which of course led to some number of speeches to me about how unfair that was, and so on and so forth, which I said, okay, what priority sequence do I use? Screw the people who are going to graduate? Tell me. And realistically, what happened was we were not equipped for the load of students, flat out. We had no idea that there would be that many students. We knew conceptually, but we didn't know. It was a really interesting experience as a result. And what we had to do, of course, was I said we'll have a summer section and a fall section, which of course led to some other operators of a different sort rethinking their plan to graduate. A few people telling me, well, I'll just graduate and I'll do this. And I said, no, not happening. Sorry. I said, we don't negotiate on that. But in any event, that would be an example of what happens if you had the experience of being in that class, of when you don't have enough capacity. Another example of something like not enough capacity would be there's a change in some federal law. People go out and buy more of something. And then all of a sudden the manufacturers are backlogged because they hadn't anticipated. A more practical sense, and something you could be involved in almost immediately when you leave here, is intermediate term planning, where you look at how much do we make, how much inventory, how many people, and typically you're looking at the next 6 to 12 months. So next fall, for example, we're planning right now. And the schedule's due, and we'll come up with some. No doubt there will be some other thing that doesn't happen correctly or what have you, but it gets fixed. Alternatively, how we deal with this is what? We hire an adjunct. Or we make another section. Or we do something else. One of the big problems on campus right now is the Jet Hall renovation. Took a lot of computer labs and a lot of nice classrooms out of commission for 2 years. So even if we had an instructor, we might not have a place to teach it. That's a capacity issue. Even offices are a capacity issue. Do you have enough places for people? Okay, when people plan production, they're actually usually looking to minimize cost or maximize some service objective. I want to always have something. Essentially, this goes back to the famous question of what business are people in? Are they in the business of selling something as cheaply as possible? Do they need a higher quality product? Do they want ultimate service? For example, if you have, some high-tech product that's a complex system and there's a lot of spare parts that need to be stocked, you need to plan to make the spare parts and have them available where people can get them. So in a schematic sense, a nice picture from the textbook is 1 to 5 years out, we're looking at the product design and the product mix. Where are we going to do this? How are we going to do it? We're going to 3D print everything, right? Buy enough printers? Six to 12 months out, we're thinking about how many workers do we need. Now, in a lot of textbooks for this class, they'll go through employment cycles. And that always seems a little creepy, like hire workers, lay off workers. But it could be a reality. Do we need to plan an overtime budget? An example of this you've all experienced would be, what places hire lots of people in, say, September through November? Stores, right? You can't have the store open 24 hours with the same people who kept it open 8. You need more people. UPS and FedEx, they need more loaders, more drivers. People can't take vacation around then, right? It's a peak season. That would be an example of aggregate planning. We know that starting in November, more people start coming into the stores, right? And you can't have new people start like, say, the famous Black Friday, right? That's a recipe for disaster, so people start being brought in, and then all of a sudden, they're no longer needed after the return season. And some of them stay, some of them don't stay. In a short-term setting, now we're thinking about who comes to work when, what are we making, and ordering materials. One of the interesting things that came out for you guys is we're required to order textbooks quite a few months in advance, which is another headache for me in my department head role, since I get these hateful emails complaining that Dr. X, Y, or Z hasn't turned in their textbook order. The reason is that there's a federal law that requires that we make the textbook title and ISBN available to you guys early so that you can shop the market, which clearly is a law that was designed for who? Most students I know, what are they doing about textbooks, do you think? I asked people, I said, what do you do? They said, oh, I look on Amazon, and then I look on this, and then I know I can't trust you, so I wait till the semester starts. Somebody said, I said, excuse me? When have I changed it? Well, not you. Those other people. Okay, great. But in theory, the reason for ordering the textbooks early is so that the bookstore can make it known to you guys what you're expected to buy, and you can shop the market. Which, giving you more than about a week to do that, 2 weeks, 3 weeks, seems like the vision of someone who was buying their textbooks when? Because realistically, what would you guys do? Get online and look, right? If you know the ISBN is blah, 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 you type that in. Search engine tells you what editions are available. Someone writes in and says, is it okay if I have the 4th edition of the book that's at the 9th edition? And I said, well, only if you're going to class in 1987. But that's up to you. Usually I'm okay if you got one rev back or an international one. After that, it's like your risk. So, any event, scheduling, important. Aggregate planning, important. What do we sell customers? For example, air conditioners. I just happen to be thinking about air conditioners and furnaces, so imagine you go to work for Trane or Lennox, one of those outfits, right? They sell what? Air conditioners, furnaces. They have to plan what? How many of those things they're selling to customers, right? What sorts of machine shop facilities, sheet metal shop facilities, electronics facilities, right? If you look at a furnace that is sold today, there's a lot of electronics in it. This furnace from 88 years ago is all electromechanical, if that. So if you have electronics in the thing, you need an electronic shop, or you need a vendor to make the electronics, right? You need an assembly shop. You need, as we said last time, the ability to distribute this stuff, ship it, and so forth. A lot of people who plan for part families. It's officially called group technology in the literature, the idea that you have some number of things that you make in an area and they may vary. An example would be like making t-shirts. You got small, medium, large, extra large. They're all different dimensions, but they all use the same material, different cut pieces. But the sewing is exactly the same. Sometimes people think about product types. This could be the facility you work in that does this type of product. When you think about end items, in most businesses you're also thinking about spares. What things likely fail and need replacement? And usually spares are planned as a separate line of production. I'm going to make 100 air conditioners a month, or 1,000 air conditioners a month, is sort of an aggregate plan. What do I need to do that? Well, I call up my manufacturing engineer, and they tell me you need so much per system of each type of resource. I call up the purchasing and bill of material people. They tell me you need steel, you need this, you need paint, you need these things. I can plan that. Now, that would be an aggregate level of production, 100 a month. 100 of which ones? Answer: 6 to 12 months in, I start to think about, all right, which models am I actually making? And if you think about it, suppose I make the wrong models. What happens? If the market wants Model X and you've got a whole bunch of Model Ys, either A, you're not making a lot of sales, or B, you've got to come up with some strategic pricing decision. So if we think about forecasting, we forecast, and that drives a lower level forecast. If we go far enough down this chain, we can calculate. So if I want to forecast some product, like air conditioners, I just happen to be thinking about that, I might make 12 models of air conditioner, all of which might use the same materials but have different size motors, different size condensers, heat exchange, whatever, right? But I know I'm going to make 100 a month. I can plan a plant that way. I can't make them that way. I can set up, I need how many square feet of sheet metal shop, how many square feet of machine shop, and so forth, based on I'm making 100 a month. but I can't really actually make them that way. Make 100 whatever you want? Not exactly possible. Also bad for the customer. And if it's bad for the customer, who do they go to? You or your competitor that does a better job planning, right? But the way to think about this is I'm forecasting at the high end, and I'm trying to validate it as I go. As I get closer in time, I try to reforecast at a finer level, and then eventually I can just calculate what I need, right? I have a parts list. I know I need 100 a month, so I might be making 20 of one model, which means order 20 motors and so forth. If I need 20 motors, then I need somebody to make some mounting brackets, and that I can calculate. So we start to get what looks like a family tree, and this again is from the textbook, but they use pumps. I used air conditioners. You could use chocolate bars. Doesn't matter to me. The concept's all the same. If you prefer, you could use anything. I can plan to make pumps. To make pumps, I need certain types of facilities and certain types of people. And I know I will need some types of material. As I get more knowledge, I now know more about the market. And to be honest, I don't know anything about making pumps, which is not really an issue. I know I have a product type. I have families of pumps that there might be 3 of each type. At the high end, I know I'm making 1,000 pumps a week. And I've planned that facility 3 years out. And now we get to, now I'm looking at September of this year, what product mix should I make? Now, when we get to talking about this in more detail, we'll look at the concept of make to stock and make to order. Make to stock means I have them in stock and I sell out of my warehouse. Make to order means you have to order it, and then I make it. I was at a meeting yesterday of a group I am involved with, and they were talking about people locating plants in Doña Ana County, where we are. And whenever people get into those kinds of conversations, I sort of listen and wonder. And what makes Doña Ana County a cool place to do business? No Doña Ana County enthusiasts in the class, huh? It's actually what's good about it. Plenty of open space, right? Weather's great most of the year. In fact, it will be hitting the 80s later this week, which in February seems pretty primo, right? Got a university and DACC, the community college. labor rates are relatively lower than some of the country. Material prices are the same everywhere, but if I'm dealing with some types of material, I might need to forecast what the material prices would be. You have electronics with gold in it, the price of gold is pretty important. What might my holding cost be to keep inventory around? But these folks were talking about, would people locate plants in Doñana County? I, of course, just sort of listened, and they said, well, you're from the university. I said, we're ready. Plenty of engineers graduating. And actually, one other thing you might not even be aware of is in Santa Teresa, we're a free trade zone, and Santa Teresa has an outstanding intermodal facility. Union Pacific spent $500 million on a rail facility with trucks and things like that to support cross-border traffic. Sounds like a great place to locate. But the conversation continues. There was no resolution as usual. So that was cool. Okay, so in any event, what am I planning? How much labor costs will be? How much overtime? Do I need subcontractors? And then we do what we call a rolling horizon. We roll forward each period as we plan. Depending on the corporate entity you talk to, they will have different versions of this. They will all be sure theirs is correct. Either that or they sent the wrong guy to the career fair. If they're not upbeat about their employer, they shouldn't have gone to the career fair, right? Okay, more seriously, what are we doing? Remember this from many of your classes. This is plan, do, check, act. Or if you would prefer, it's a feedback loop. Whichever you prefer. Plan, do, study, act, define, measure, analyze, improve, control. If you're a Six Sigma fan, hey, we serve all types here. What do? We go out, we get the results, we take a look. Should we change anything? If not, why not? If you can't convince yourself to change it, then don't change it. One of the interesting examples of this that I use because students are familiar with this is every so often somebody asks, how come we don't get more faculty in the IE department? And I said, well, we just got a new one. Nice person, you should meet her. Right? And they say, no, you guys need like 3 more people. I say, yeah, I've been told that before. And they say, what are you doing about it? And I say, I've discussed this with the management I report to, and they wish me well in my current setting. What's going on? Got to pay these people, right? Got to have resources, and so forth. Universities are great environments for seeing the results of not planning and also the results of not funding growth. Now, the point isn't to criticize anyone. The point is we're not exactly an agile organization. We don't turn on the proverbial dime. It takes a long time. I've been working on a project that I talked about last semester because I had to go present it to the state. And I'm still laughing because somebody asked me recently, they said, how's that going? I said, it's at the state level. They said, well, when do you think you'll know anything? And I went, they said, but that's a great idea. I said, that's what they told me 5 years ago when they got me started on this. The system's not as agile as it seems like it should be, right? It takes a long time to move organizations. So the point of this, besides it's a funny story and it breaks up the class, is the idea that in theory you need to be agile in planning. In reality, you might not be able to be. It could be next semester. So those of you who graduate may get an alumni thing that says, it finally happened. What we would do is implement, and then we would look and drive it through the plan. What would be an example of really screwing up a plan? A popular one right now would be our friends Volkswagen. What did Volkswagen do? Apparently commit a number of felonies. In fact, one guy was got some prison time, one of the lead engineers. Volkswagen was making cars that had a test mode to ensure proper emission standards were met, and then when it was driving around was actually blowing, shall we say, significantly more pollutants out. That's a good way to screw up your plan. Why? They got caught, and now who's buying a Volkswagen? Or if your plant burns down, or some other product's liability thing, Takata airbags. That's a great story for a quality control class and a professional ethics class, Takata airbags. They screwed up their production scenario quite excellently. How'd they do that? They went with a product that has a habit of deploying unexpectedly and causing, you need a lot less people and equipment when you're under indictment. How else can you screw up this thing? You could forecast the wrong product. Easy enough to do. Or under forecast the correct product. About, too many years ago to say, I was teaching this class and I was looking for an example that would intrigue the class. And it happened that I had read an article in the New Yorker magazine about the then craze for Manolo Blahnik shoes. These are expensive designer shoes for women, and they were made popular by the show Sex and the City. So I started telling the class about it, and I said, you all have seen this show Sex and the City, right? So, of course, the students are all looking at me, and I said, well, those shoes, right? And it happens that in the article they mentioned the day of the week that the Beverly Hills Neiman Marcus got its shipment of the shoes, and the fact that there would be a line outside the store at 10 a.m. waiting to get in to get the shoes that Sarah Jessica Parker and company had worn in the previous week's show or something. And I said, now here's an interesting challenge in production and inventory management. And of course, half the class is looking at me like they're trying to figure out if it's really true that I've seen Sex and the City. The other half is wondering where this is going. And I said, really simple. If the shoes aren't in the store, they can't be sold. And if they can't be sold, you have no cash flow. And then, of course, at that point, when they realized it was serious, there's another half of the class wondered why anyone would spend $650, $700 or more for a pair of shoes. And we all know who they were, right? And we all know who was thinking, I wish I could buy a pair. And I still said, it doesn't matter in this class. What matters is you have to have them in the store. You have to plan your production accordingly, because if they don't go in the store, what happens to them? You don't make the sales, nobody gets any cash flow, which to me seemed like the whole point of the story. But again, if you think about it, try look at some product you see, I don't know, Lady Gaga or Kim Kardashian wear, and watch what spikes demand. All they have to do is be seen a few times wearing it, and of course every picture gets retweeted and whatever all over. And I'm not criticizing anything here. I'm just saying if they wear it and people want to buy it, it has to be available to be bought, which means back here you had to plan to have it in the store. And the store had a plan to buy it and all that. So there it is. ie424 and 524 is happening in real life in front of you, and you didn't even know. You got to forecast it so you can get it made, get it into the store, right? It has to be there for people to buy. But that did turn out to be the last time that I had the bright idea to use a TV show. But the story is funny in and of itself, mostly because, as I said, half the class was wondering how I knew that that show was on, because their image of me precluded any possibility that I would have been watching it. And I said, I live in a closet in my office, right? I only come out to teach class. Okay, so any event, when we're looking at aggregate planning, we can do two major strategies. And one is to try to chase demand. The other is to produce a level amount. Chasing demand can cause a lot of grief for people. The idea is we adjust production to match demand. And this works well for make to order. I have not much inventory around. There are two types of inventory here. Really, three. Raw materials and parts, pretty obvious, right? If you make parts out of sheet metal, you got to have some sheet metal. You need paint, right? That's pretty straightforward. Work in process inventory is once you start making something, it becomes work in process. Finished goods inventory is stuff that hasn't been delivered yet. It's sitting in your warehouse. Now, if I chase demand, I buy inventory and release work to match the schedule for the customer's finished goods. So say we go back to the high fashion shoes, the raw materials are like the leather and the buckles and the color, the heel material, all that kind of stuff. Work in process are shoes that are being assembled. For example, Allen Edmonds, who I mention occasionally, they make higher-end men's dress shoes and casual shoes. They have a 212-step process. Once you start the process, the shoes come out sometime later. So all the time they're in step 1 through 212, they are work in process. Then they become finished goods that get sold to the customer. Some disadvantages. This is for those of you who might be thinking of going to work for the Raytheons and Lockheed Martins of the world. This is their classic issue. They hire people as production increases, where they run a lot of overtime and extra shifts, and that brings its own weirdnesses. Again, the defense industry is the classic example here. I don't imagine this has changed. I work for a defense contractor. The endless discussion of when layoffs would start was endless. There was always rumors of people being laid off. And interestingly, people would watch the raw material and work in process inventory, because if they didn't see enough inventory on the floor, they assumed that the need for their services would go away, which would lead to another morale discussion. And also, when you hire and fire people a lot, the people who are actually your best workers are usually the ones who are employable elsewhere. And they might choose a different employer, thereby ruining things again. So this is all quite real. And some people in the class who are a little older may have already been through one of these cycles, or more. I mean, certainly I saw it more than once. And production forecasts drive proposed staffing levels and so forth. And people do respond to these things. A couple other disadvantages of chasing production at an aggregate level is you got to have enough capacity where you have to hire someone to do the work. Now, the classic example is if all you've ever been is an undergrad. Imagine, if you will, you have a lab group with 4 people in it, and you're the high achiever of the 4. And someone else in the lab group takes on the role of underachiever. Are you thrilled to have that person along for a ride? No, right? Now, since I happen to know most of the people in this class, we could paint some interesting groups, but we'll leave that alone. Because usually if someone like me says who thinks they're a high achiever, everyone raises their hands, which occasionally causes an amusing outcome. Nonetheless, if you hire a subcontractor, they have to be what? As good as you are at doing it, or better, right? Otherwise, what do you have? Now you have a quality problem. And the other thing, by the way, if you haven't locked in the subcontractor or vendor early enough in your planning process, they may have gone on to do something else. And they may not be available, the good ones, and all you get is who's left, which may not be the people you want working on your product, right? And the costs of idle capacity are quite high. Hiring, training, terminating, that gets expensive. So chasing demand can be efficient in some ways, but expensive in others. Graphically, what that's going to look like is demand and production try to track each other. How good you get at this has a lot to do with how good you are at doing your job and how good your customer is. Because imagine we're trucking along making this thing, whatever it is, air conditioners, shoes, whatever, toasters, nuclear medicine products, whatever. The customer orders it and cancels an order. What do you do with all this stuff? Tough question, right? Or it doesn't pay on time. One of the things with work in process is as you put work into process, you start to incur costs, right? you've now have material that's being worked on, parts that are being assembled. Somebody got paid to do that. The money that pays them is supposed to come from the customer. Now, of course, what you have to do is have investors on the front end, or your own money, so you can move along until the customer starts sending in cash flow. But you'd be surprised. Customers are slow payers. Universities are a good example. Occasionally, the federal government in the U.S. is noted for being slow to pay. That can become an issue because as you chase production, you've incurred cost, right? And who's paid for this? You have. Your customer doesn't pay till period 18 for the stuff you delivered in period 3. That's an ie524 or 523 problem. How much did it cost you to hold on to that bill for 15 periods? So that's chasing demand. The other is what's called level production. Now, what you guys do as students is chase demand, right? We give assignments, you respond to them, right? That's chasing demand, right? We create a demand, you fulfill. You would prefer to have a level production strategy. And as I was joking earlier, of course, that's not what usually happens, right? Because we all get together and decide to have tests on the same day. How did they do that? I said, oh, we had a faculty meeting. Oh, it's that time of the semester. If I could forecast the average demand, I could create an environment where I have relatively smooth operation. So if I forecast demand of 100 air conditioners a month for the next 36 months, I could actually calculate how many people, how much material, and so forth, and then do minor adjustments as I go. One of the advantages of the stable workforce is that they know they have a job. They're not thinking about, maybe I should find an employer who can do this correctly. The major issue is, of course, that people build up inventory. But this is an alternative to chasing demand. I could come up with some level production. I could also do what? I could add a trend or seasonality to my forecast. If I think more people will be buying air conditioners over the next 5 years, what would lead me to think of that? For example, housing starts. If I knew that more people were building houses and I sold air conditioners that go into those houses, seems like a very reasonable possibility, right? It might occur to me at this production plan level to consider increasing capacity. Or I could look at neighborhoods where I have dealers of air conditioners and wonder about the age of the air conditioners on their houses. Nice data mining exercise, right? Air conditioners last 10 to 15 years. Lots of these were installed 20 years ago. Maybe they need more. Wouldn't be a nice data mining exercise, wouldn't it? You probably need more restrictions and constraints, but you could do that. Problem is, you build up inventory and you've got a lot of work in progress and finished goods that might not get sold for a while. And the answer to so what is, if you can afford that, not a problem. The cost of the credit for building up the inventory here is what? All along here, if demand goes like this and production goes like this, all along here, what am I doing? Selling less, right? Along here, I'm selling more than I produce. This stuff is getting sold here. So essentially, what have I done? I made a bunch of air conditioners or shoes or what have you. And what do I do with that? It just hangs out. Now, where you guys have seen this, and you see this a lot this time of year, is how? A sale. Because what happened? Somebody forecasted what was needed. It didn't sell. We need to get rid of it. What do we do? See if someone will buy it for less. Now, interestingly, the manufacturers of many consumer goods hate that strategy. Surprise, right? Because what does that do? It trains people to do what? Buy things on sale. Which leads you into a never-ending cycle of building things to sell at one price, and then it sells at a lower price, which trains people to do what? Instead of buying it now, wait until... I'll give you an example. In a few weeks, we'll be celebrating Engineer Week, right? All the engineering students will be participating in games of skill and parties. It will also be President's Day, right? Great time to do what? Have a sale. Lots of sales, right? Why buy now if 3 weeks from now you can get it at 20% off? Which is great unless you're waiting to do what? Get paid. So as you can see, you can actually train the market to shop when you have a sale, and that may not be helpful for your production strategy. Pretty neat, huh? You can model this. Fantastic. The data are out there. Because why would you buy it now if in 3 weeks you can buy it for whatever? Interesting, eh? It's happening out there every day, all this stuff. And that's what's really cool about it. We are out of time I'll see you next time. Have a good day, everyone. Check out those problems.